Hello everyone, this is the new Generation Airships project again. It's me again, Kanari Babanin, and in this video, we'll talk about the results of April. We'll find out what was accomplished during the previous period and discuss what plans await us in the future. Friends, we're right in the thick of things. The active assembly of the Nova 01 airship is happening here, along with our first preparatory work. Let's try to find out the details. Fedor, what's this box?
This is the onboard computer, but that's for the future. For now, it's really just a box that will be located right here, hanging. Inside it, there's a port computer, a switch, a flight controller, a modem for receiving signals, and a radiator for cooling. The modem isn't installed yet, and a power supply will also be added. Today, we'll connect all of this, power it up, and check how it works.
Friends, Artyom is our main person who will be responsible for conducting the flight tests of our Nova 01 airship. Right now, we're in the stage of active preparation, and I'd like to ask Artyom how the preparations are going, what data we plan to collect, and what expectations we have for the flight tests.
At the moment, we're currently building this model, which is specifically intended to obtain the physical and mathematical parameters from the flight tests. Accordingly, we'll be collecting speed parameters, pressure parameters, acceleration parameters, barometric pressure parameters, angle parameters, current consumption parameters, and so on. There are more than 150 of these parameters in total. All of these parameters will be organized and entered into specific tables during the flight. We'll study these tables afterward. Based on the comprehensive data we carefully collect, we'll build a device that will serve as a prototype specifically for unmanned airships of this size and form factor, in order to ensure optimal performance. Right now, this is just a model. It's as cheap and simple as possible, so we don't mind if it breaks or gets damaged. The most important thing is that a large number of sensors will be installed here. An airspeed sensor, barometric sensors, temperature sensors, sensors to measure the current consumption of the motors, and battery discharge sensors. Sensors for pressure inside the balloon, sensors for the temperature of the gel inside the balloon, internal pressure sensors, as well as sensors for ambient pressure. All of this will be analyzed, and then, based on this data, we will improve the design, creating a more advanced version, which will look so much better, far better than the device, the piece of equipment that we've built here right now. There will also be a large logbook here. Actually, these aren't tables, but samples of test protocols and measurement protocols. Accordingly, there will later be a fairly large, thick notebook compiled from these values, because measurements will be taken every day. For example, the measurement protocol and environmental parameters will be recorded several times a day. So, things like temperature, pressure, humidity, wind speed, and illumination in lux will be recorded here. This is in anticipation of using airships with solar panels in the future. The weight values of all components and parts will be listed here as well. Parameters of propulsion and auxiliary units, evaluation of steering control operation. Every single angle will be carefully and thoroughly recorded, correlated, and compared with the signal we send to the steering servos, and directly with what the control surface itself indicates. The overload will be measured, as well as parameters such as speed, airspeed, barometric altitude, and the rate of climb, as I mentioned earlier, of course.
Friends, and of course, Shamil is also actively involved in preparing for our flight tests. Shamil, we have a bunch of different tools, equipment, tubes, and hoses here. It would probably be interesting to hear about this net. What role does it play in the airship?
This net for gas filling was made according to this drawing. Its purpose is to keep the envelope from flying away when it's being filled with helium and to keep it at the height we need. Part of it is tied to the net and part to the bags through these loops. And when we install our equipment, we set the required height using this net and secure it in place. Then we move it up to the next level and install the stabilizers and various other components.
So this net is spread out over the entire surface of the envelope. It's filled with helium, and as a result, it rises. The net keeps it at the desired height. And instead of having people stand there holding it, we use these bags filled with sand.
There was a lot of design work involved. That means assembling the 3D model itself, manufacturing all the components, compiling the weight summaries for each part and each unit. There was also work on the production side, which we usually took part in. For example, we riveted these gondolas and stabilizers ourselves, and we also did the painting.
You worked on the mooring lock too, right?
Yeah, that's right. We model it, do the weight calculations, and then manufacture it in metal.
Painting work. Shamil really plays a big and important role in the development process. At least, he was involved in the Nova 01 airship. He's like a jack of all trades at AERONOVA. We conducted ground tests of our first envelope for the Nova 01 airship. We checked its strength characteristics, its airtightness, and then carefully filled it with air to test the seams, and also thoroughly checked the ballonets themselves for airtightness and strength. We also checked for the presence of all the necessary pockets where our gondola will be installed and secured. We checked for all the technical openings where valves and fans will be installed. We tried on all the necessary equipment that will be installed on the gondola, made sure everything was in its place, and with that, we wrapped up. We made sure that the envelope really meets all the required technical standards set for the Nova 01 airship. We packed up our envelope once again, and are now just about carefully getting ready for the actual flight tests. At the same time, our work on stratospheric launches continues. Right now, our partners have developed and tested an envelope for a stratospheric craft with a volume of 500 cubic meters. They carefully checked its airtightness, its entry and exit from the hangar, automated launch, and also the payload drop during flight. So work in this area is also moving along quite actively. Our machines from China have finally arrived. Just the other day, we received a lathe milling machine, a 5-axis milling machine, and a metal EDM machine. We've already successfully moved these machines to their designated workspaces. They're being set up and fine-tuned, and very soon, they'll be up and running. The AERONOVA team participated in the 22nd Scientific Conference on Aviation dedicated to Nikolai Yegorovich-Zakhovsky, where they presented various reports in their respective fields. The team showed engagement in theoretical work and research, but we also directly launched stratospheric vehicles and work on developing airships, such as high-altitude platforms, which actually generated significant interest from the scientific community. The team faced a particularly large and challenging amount of work in developing their own custom software. As we mentioned earlier, there aren't many companies that develop software for flying vehicles in general, and even fewer for airships. That's why we had to develop and implement the necessary software ourselves for our specific needs. This software has already been developed, and the next step is to move on to testing it. We will launch the airship, and then we'll start collecting the necessary database that this software will use to learn how to behave in different situations. Initially, rain, wind, magnetic storms, and vast open fields. Anything at all can happen during a flight, and this advanced software always needs to make the right decisions, no matter what. This is our first airship. We have a new team, a fresh group of people, and we need to build effective collaboration and establish the right organizational process. That's exactly what we're refining right now with this first small airship of ours. Despite this, the company is confidently moving forward, and very soon we'll see our first airship, Nova 01, in the sky. Stay tuned and follow the project.